Hey folks, Jake von Slatt here. Today we're out in the Forge and Foundry area, and I'm going to build myself a table for preparing molds for casting. But I'm going to be using the engine-driven welder for that, and I wanted to run you through some of the upgrades. Basically, I replaced the panel, and I did some of the things that I talked about in the earlier video. Just as a reminder. This is an engine-driven welder that I bought on eBay. The engine is from a 1946 Austin Dorset. It's a 4-cylinder cast iron block engine, probably weighs 500 pounds. And originally it drove a 400 amp aircraft generator. That generator was burnt out when I got it, and I replaced that generator with a 250 amp heavy-duty Ford alternator. Which you can probably just see down here, and took the diodes out of the alternator, put in a large 400 amp 3-phase rectifier. You can take a look at the earlier video, just search for Rat Welder, and you can see the details of it. What I've done more recently is I've replaced the panel, and I put in this large knife switch that allows me to switch between a delta configuration top and a star configuration. You get more voltage with a delta configuration, and that makes running a rod a little bit easier. In the delta configuration, you get more amperage but lower voltage, and that seems to work better for MIG welding, for wire feeding wire. In addition, I added connectors for the cable, so I can swap polarity easily, depending on whether I'm running MIG with gas or without gas, or doing scratch start TIG, which I have not yet tried on this machine. These two connectors go to the alternator, two of the coils on the alternator, before the rectifier. So the idea is I'll open the switch, I'll connect up the TIG torch and ground to these two connectors, and then I should be able to TIG aluminum, because this is AC. It's going to be fairly high frequency AC because of the alternator. I've not actually tried this yet, but I wanted to be able to do that experiment. Let's see, one other thing. Previously I had a large rheostat for adjusting field current for the alternator to adjust the ultimate output current of the welder. I've replaced that with a PWM controller, pulse width modulation controller, basically a motor speed controller. This is an eBay one. I think it's rated for like 60 amps at 12 to 48 volts, something like that. It was like $20 on eBay. And that's what this knob controls. This is the current that goes to the field current in the alternator. This switch switches out this potentiometer and connects this connector. And the idea there is, if I am going to do TIG, AC TIG, or DC TIG for that matter, I can connect a foot pedal here and adjust the current. Again, have not tried that yet, but that's what these controls are for. These controls down here, this one turns on the field current and pulls in a solenoid that hits the throttle. This is the cutout for that solenoid, so if I'm welding something small, I can just leave it idling and turn on the field current. I did put a 300 amp shunt in, and it looked like I was getting about 200 amps of welding current out of this alternator in DC mode. But it very quickly blew up the meter. So the shunt's still in there, and I may replace this meter and put a push button switch so it doesn't stay in all the time, and then maybe that'll make it last a little longer. Also, maybe I'll put some surge arrestor or something on the meter to try to save it. This is alternator voltage for the alternator that charges the battery. So this usually reads around 12 volts. This basically tells me the alternator that charges the battery is working. This is voltage for the welding alternator. And typically I get 50, 60, 70 volts welding in welding voltage in star mode, and about half that in delta mode. The delta mode also seems to put more strain on the engine. My RPM, welding RPM, is lower when it's in delta mode. Oh, and this connector here, this is just a remote control for speeding up the throttle and turning on the armature current. So I can do that from the electrode. That's about it for the upgrades to the welder, and I'm going to get started on making that mold bench. Okay, to make the mold bench, I'm going to be using this. This is a spool gun, and this was an eBay purchase. I think this was, I don't know, I want to say it was like 39 bucks. It was pretty inexpensive, and it's a spool gun. It is loaded with flux core wire, which is what I typically use outside for crude things. It does have input for gas. I haven't tried it on gas yet. I mainly use it for the flux core wire. It's a 24 volt gun, so I'm running it off of 2 of these 12 volt 7 amp hour batteries. I've got a 20 volt charger in for charging it up, and then up under the cover, another one of these $10 PWM modules. That's how I control wire speed, with that PWM module, and it's very steady control. So basically, I just let's see. I think I have to turn it. There we go. So that's all it really does, is feed that wire. Very simple, straightforward. And with the PWM control, I can control how slowly that goes, right down to a pretty slow feed. All right, and then I'm going to rewind this. And this basically just clipped the electrode here for the engine-driven welder. So that's what I'll be using to build this bench.
For production.
I think that'll do it for now.